Hey guys, today we're going to take a look at lesson 5.2 in our packets. We are still talking about probability and normal distribution. If a random variable x is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve for that interval. And last class we talked about normal distribution and standard normal distribution, how we can take any value on our normal curve and turn it into a standard z-score using our z-score formula. Okay, and they're going to find the same thing. P of x is less than 600 is the same as P of z is less than 1. So, example 1, a survey indicates that people use their cell phones an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that the user will use their current phone for less than 1 year before buying a new one. Assume the variable x is normally distributed. So looking at the left, our normal distribution, our mean is 1.5 and our standard deviation is 0.25. We know that from our story. So here we have our picture of our normal curve. We're looking for less than 1 year, so that's to the left. Now we want to turn it into our standard normal curve. So we put it through our z-score formula. So x is 1, our mean is 1.5, and our standard deviation is 0.25. So if we work that out, we get a z-score of -2. So that's what we're looking for. We're looking for our z-score of -2. And everything to the left of it. Now remember, for our standard normal curve, our mean is 0 and our standard deviation is 1. So go to the standard normal table on page 7 and 8 and find the area to the left of a z-score of -2. Okay, hopefully you got a chance to look for that. The area on the standard normal table that's to the left of -2 for our z-score should be 0.02275 or 2.28%. Let's take a look at example 2. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store is normally distributed and is represented by the variable x. A shopper enters the store. Find the proper probability that the shopper will be in the store between 24 and 54 minutes. So let's take a look here at our normal distribution. Our mean is 45. Our sigma, our standard deviation is 12. And we're looking between 24 and 45, the shaded area right here. So we need to find the z-scores for both 24 and 45. So we plug in 24 here, and we plug in 54. Oops. And then 54 minus 45 over 12. That's going to give us a z-score of -1.75 and 0.75. So we will put those on our picture. And to our equation here, we want the probability of 24 is less than x is less than 54, or the probability that -1.75 is less than z is less than 0.75. So we want to go to our standard normal table and take our bigger area minus our smaller area to find that area in between. Okay, hopefully you got a chance to look for that on the normal table. You should have gotten 0.77337 and 0.04006. If you do that subtraction, you're left with 0.73331 or 73.33%. Example 3 wants us to find the probability that the shopper in that same store will be in the store for more than 39 minutes. Okay, so our mean is still 45 and our standard deviation is 12. We're looking for everything to the right of 39. So we do 39 minus 45 over 12 is going to give us negative 0.5. Okay, so we're looking for everything greater than negative 0.5. So when we work that out, we're going to do 1 minus the area we find on the table. The area we will find on the table should be 0.30584. 1 minus that will give us 0.69146, or 69.15%. Example 4 wants us to apply what we just learned. If 200 shoppers enter the store, how many shoppers would you expect to be in there for more than 39 minutes? So we have our 200 shoppers. We want to multiply by that percent that we got last time. Make sure we write it as a decimal. So we multiply it by the 0.69146. And if we do that, we will get 138 shoppers. So 138 shoppers will be there for more than 39 minutes. So we don't only have to use the standard normal table to find our probability. We can also use technology. We can use our calculators. So when we're looking for the area to the left, when we're looking for P of X is less than a number, we're going to go to second vars to normal CDF. Our lower is going to be negative 1 E99. The upper is going to be whatever number that you're looking at. Mu will be your mean, and sigma will be your standard deviation. You plug in those numbers, and you will get your answer without having to convert to a z-score or use the standard normal table. When we're looking for the area to the right, probability of X is greater than your number. You'll go to second vars to normal CDF. This time your lower is going to be your number, and your upper is going to be 1E99. Mu is your mean. Sigma is your standard deviation. And then if you're looking for in between two values, P of numbers less than X is less than number. Your lower will be your lower number. Your upper will be your upper number. Mu is still your mean. And sigma is still your standard deviation. So there are some examples on this check for understanding. So if you've got a calculator, go ahead and try the next 3 examples, pause the video, and come back for the answers. Okay, hopefully you got a chance to try those. When we're looking for area to the left, less than, and we use our normal CDF in our calculator, we should get 0.2896 or 28.96%. We're looking for to the right of 600, put that in our calculators. We should get 0.2092 or 20.92%. And when we are looking in between that 450 and 600, we're going to have 0.5012 or 50.12%. And one more. The last thing is that when we are using that technology and we're given a z-score, so we're asked for the probability of z is less than a number, or z is greater than a number, or z is between two numbers, it's going to be that same process, that normal CDF, except remember for our standard normal curve, our mean is 0 and our sigma is 1. So for all of these examples, we would use that same, like lower for to the left would be negative 1E99. The upper would be negative 0.76. Put in your mean of 0 and your sigma of 1. So go ahead and try these 3 problems. Pause the video and come back for the answers. Okay, here are your answers. Go ahead and check them and make sure you come in with any questions.